we're going to take a couple minutes here to talk about the concept of an antiderivative. In other words, what happens when we work backwards from derivatives. So the concept of starting with a derivative and then working backwards is going to produce what we call an antiderivative. Antiderivative. So f of x, big F of x, is an antiderivative of little f of x if it can be said that the derivative of big F of x equals little f of x. So in other words, if I take the derivative of something, that means little f of x is the derivative of big F of x, which means big F of x is the antiderivative of little f of x. It's kind of like the idea of an inverse function, but it's just saying if we undo it, what do we get? Note that there are many possible antiderivatives of a function because the derivative of a constant is 0. So for example, f of x, little f of x, is equal to 2x squared plus 3. Big F of x, sorry, getting too low and my tablet pops out on me. Big F of x could be equal to 2/3 x cubed plus 3x, or 2/3 x cubed plus 3x plus 1, or 2/3 x cubed plus 3x plus 5, etc., etc., etc. I can pick literally any c at the end there because when I take the derivative, the 2/3 x cubed is always going to give me 2x squared. The 3x is always going to be 3, but that constant will go away. So all of those are antiderivatives of little f of x. There's not just one. So to find an antiderivative, in other words, an indefinite integral, we look at the rules for derivatives and then we try to reverse the process. So if it's possible to reverse it, we reverse it. So for example, the power rule, the integral of x to the n of dx is equal to 1 over n plus 1 times x to the n plus 1 plus c. So in other words, normally we multiply by the numerator, and then we subtract one from or multiply by the exponent and then subtract one from the exponent. So in this case, I added 1 to the exponent, and instead of multiplying, I divided. Then we always add this c. This is the constant of integration. And it represents the fact that any constant could be added to this, and they're all properly antiderivatives of this. So for a given function, if I don't have any reason to pick one value of c over another, I need to always include this. You will lose points if you leave off c when it's supposed to be there. Likewise, you'll lose points if you put it on when it's not supposed to be there. This is one of those things that just, with practice, you'll nail it by the end of the semester. So this is the idea of the antiderivative, is look at a derivative rule and flip it around.